Hello and welcome. Today in this video we are discussing Tieset matrix, or it is also called as a fundamental circuit matrix. It is part of graph theory. Fundamental circuit matrix or Tieset matrix is a rectangular matrix in which the row resembles the fundamental Tiesets or loops and the column resembles the number of branches. A fundamental Tieset contains only one link branch and the remaining twigs branches of a tree. Now, what is link? What is twig? What is branch? We already studied this in a previous video. Just go through the previous video so that you can understand these concepts. Now, how to form the fundamental loop matrix or Tieset matrix? First, select a tree of a directed graph. How to select a tree, that also we have discussed in a previous video. Then list the number of links. Now, by including one link at a time, we'll get one loop, that is called as a F loop or Tieset. List all the Tieset, then number of F loop or Tieset is same as the number of links. Now we can form the fundamental loop matrix or Tieset matrix. Fill all the elements of this matrix. The elements are 1, -1 and 0, same as the loop matrix. Only change here is number of rows is same as the number of your Tieset or F loop, and number of columns same as number of branches. In loop matrix, we have considered all the loops present in your graph and columns is same as the branches. But in case of Tieset matrix or fundamental loop matrix, number of rows are different. It depends upon how many number of links are there. So F loops are there. The number of links and number of F loop is same. You will understand it clearly when we will write the F matrix or Tieset matrix. Now one more change here. In loop matrix, we are considering the loop current direction clockwise. But here, orientation we are considering same as the link. That is the change here. Okay. Let's see how to write the Tieset matrix or F loop matrix so that you will understand the concept clearly. So when graph is given to you and we have to write a Tieset matrix, your first step is form a tree for this particular graph. We already know how to form a tree. For particular graph, there can be a number of different trees you can form. For a given graph, to form a tree, condition is it should include all the nodes. All these nodes should be connected and there should not be any single loop exist in a tree. So I will remove here branches such that it should include all the nodes and this should be connected and there should not be any loop. So I will remove branch 2, 4 and 7. So this is my tree. You can form another tree also, but the condition should be satisfied. It should include all the nodes. All the nodes should be connected, directed or indirected, and there should not be any loop in your subgraph. So this subgraph is called as a tree. Now next step is mark all the links. What are links? Links are the branches which you have removed to form a tree, and the twigs, the branches which is part of your tree, is called as a twig, and the links, the branches just we have removed to form a tree. So branch 2, 4 and 7 is your or are your links. Now these links will help you to form a Tieset matrix. So what is Tieset and F loop? What you have to do, next step is more important. Each link you have to replace one by one, not all the links at a time, one by one. So first I will replace link 2. So when I will replace the link 2, it will form one loop. So this is my first F loop or first tie set. I will mark all the branches of this loop or this tie set. Which one? 2, 3 and 5. So branch 2, 3, 5 form my first tie set and I will name it as a tie set 2. This 2 is related to link 2. Now next, each link one by one. Now I will remove the first one and then replace the fourth, branch 4, link 2. Second link, branch 4. So when I will replace the branch 4, it will form the second loop. So this is my second tie set. The branches which are part of this tie sets are 1, 3 and 4. So this is my second tie set. Now I will replace another remaining link, that is 7. So before that I have to move this one. Now I will replace link 7. Now which are the branches which is part of this loop? It form one loop. So branch 1, 6, 7, 5 and 3 is my last tie set. So tie sets are, number of tie sets is equal to number of links. So I have to replace each link one by one, not all at a time. If you are replacing all at a time, you may get different loops. But here for the tie set, each link you have to replace one by one. Okay. Now let's form a Tieset matrix. What are the contents of Tieset matrix? The columns is equal to number of branches and the rows are equal to number of Tieset. In previous video, we formed a loop matrix, only loop matrix, not fundamental loop matrix. In loop matrix, we have listed all the loops which are present in your graph. Here, in case of Tieset, we are considering the loops only formed by these links. That's why the number of rows in your F Tieset or F circuit matrix is number of links. Now, elements. Whenever we are writing the elements, the branches which is part of this tie set will get either 1 or -1 depending upon its orientation. In previous video, in loop matrix, we have considered the orientation clockwise, loop current orientation. Loop current we are assuming clockwise direction and the branch current which coincide with our loop current, we are taking 1, otherwise we are taking -1. So in loop matrix, all the loop current we are assuming clockwise. But here, for each loop, each F loop or tie set, the orientation is different. Whatever the orientation of your link, this 2, 4, 7. For tie set 2, orientation is according to the whatever the orientation of this branch current 2. For tie set 4, orientation is according to the branch current 4 and for tie set 7 orientation is according to the whatever the orientation of branch current 7. So if your branch current direction 7 matches for the other branches or the part of this Tieset matrix, it is 1. If it's opposite, it is -1. Let's see the element. So first, by default, for branch 2, for Tieset 2, element is branch 2, Tieset 2, because our orientation is according to the branch 2 for Tieset 2. So element is 1. Similarly, for Tieset 7, orientation is according to the branch 7. That's why the element for Tieset 7, branch 7, it is 1. Now we can go row wise, same as the loop matrix. Our first loop is formed by replacing link 2. That's why this loop for branch 2, 3, 7 will get element 1 or -1. Branch 2, 3 and 5, not 7. Now 1 or -1 depends upon orientation coincide with the our link orientation, that is branch 2. So branch 2 orientation is like this. We check whose orientation coincide. the branch 3 orientation coincide with our branch 2 orientation. That's why the element is 1. And branch 5 orientation is not coincide. That's why element is -1. So branch 3 and our link orientation is same. That's why it is 1. The branch 5 and our link orientation is opposite. That's why it is -1. Similarly, for row 2, what is our link? Link 4. So link 4 orientation is this one. For link 4, always it is 1. And what are the other branch of this loop? 4, 3 and 1. 4, 3 and 1. We'll check whether the orientation of branch 3 and 1 coincide with the orientation of our link, that is branch 4. So this is the orientation of our branch 4. So which branch coincide? 3 and 4 orientation of our link is opposite to the 3 and 4. So for both the branches 1 and 3, it is -1 because it doesn't coincide with the orientation of our link 4. Now replace it. Replace the third Tieset or third link 7. Now branch 7, then 6, 3 and 5 are part of our loop, this loop. And what is the orientation? Orientation should be according to the link orientation which we have replaced, that is this one. So this is the orientation of our loop, of our tie set. So which branch current coincide with this direction? It is 1, otherwise it is -1. So branch 6, it is opposite, -1. Branch 1, it is coincide, it is 1. Branch 1. Branch 3, it coincides, it is 1. Branch 5, it is opposite, it is -1. Like this, we'll complete row wise for the branches which is part of this tie set or part of F loop, and all the other remaining elements should be 0. So this is our Tieset matrix. I hope you understood the concept clearly. Whenever we want to form a Tieset matrix or F loop matrix or fundamental loop matrix, what are the steps? First, form a tree. Tree can be different according to our consideration. We can form a different tree. Condition is it should include all the loops, it should include all the nodes, and all the nodes should be connected, and there should not be any loop. So whenever we'll remove some branches to form a tree, that removed branches are our links. Now each link you have to replace one by one. Whenever I will replace my first link, it will form one loop, that is my first tie set. Whenever I replace second link, that will form again another loop, that is my second tie set. Once you form all the tie set, the number of tie set is equal to number of rows of our Tieset matrix, and number of columns are same as the number of branches. So whenever you want to write the element, again check the first Tieset. What is the link? The link orientation branch current is our direction to check the other element or other branch current, whether it coincide with our link direction current or not. If it coincide, the element is 1, otherwise -1. So for all the links, element should be 1. Then go for the second tie set, replace the link, check the orientation of link and write the element of second row. Go for the next tie set, replace the link, check the orientation of the current of the link, and that is our orientation, and then write the elements. Like this you can complete the Tieset matrix. Thank you.